फर्स्ट टॉपिक फ्रॉम द ऑर्गॅनिक केमिस्ट्री याचं डिस्कशन करतो आहोत रिॲक्शन मेकॅनिझम. सुरुवातीला आपण यामध्ये रिॲक्शन इंटरमिडिएट्स याचं डिस्कशन करतोय. What is meant by reaction intermediates? During chemical reaction, there is a conversion of reactant into product. And during that conversion, that reactant maybe converts into some intermediates, and that intermediates further convert into product. And these are called reaction intermediates. We have already studied first two reaction intermediates in detail. One is a carbocation, and second is the carbanion. While in last lecture, we have also started one more reaction intermediate, and which is nothing but the free radical. Now, what is meant by free radical? A species which is highly reactive and which having unpaired electron. And if that species is formed by homolytic bond breaking, then it is called free radical. We have studied introduction, then also structure, generation, and stability of that free radical. Let us see last point, reactivity of free radical. Actually, we have to study some chemical reactions of that free radical, some important reaction. And suppose first one is the photochlorination. Now, what is meant by chlorination? Actually, this is example of halogenation reaction. If replacement of hydrogen atom by chlorine, then that reaction is chlorination. And if this reaction is carried out in presence of light, then it is called photochlorination. Now we will see a very simple reaction, photochlorination. We know that suppose alkane, for example methane, is treated with chlorine in presence of ultraviolet light, we get methyl chloride. In this reaction, hydrogen is replaced by chlorine and we get methyl chloride. But actually, this reaction involves formation of free radicals as an intermediate. Now, let us see just mechanism. I'm not going to discuss in detail, but in short, mechanism for the photochlorination. Okay, suppose this is chlorine molecule. Okay, example of halogen. Now, in presence of ultraviolet light, this molecule undergo homolytic bond breaking. Means this covalent bond breaks homolytically. One electron goes towards one chlorine, another electron from the shared pair goes towards another chlorine. Suppose one chlorine having unpaired electron, second chlorine also having unpaired electron, and thus there is a formation of chlorine free radical. In first step, we are having chlorine free radicals. Now, in second step, that chlorine free radical further react with suppose alkane. We have taken example of methane, CH4. Okay, this is methane molecule. Now this chlorine free radical comes in contact with that methane molecule. Now what happens here? In this step, the bond between carbon and hydrogen, this bond also undergo homolytic breaking. In presence of chlorine free radical, the bond between carbon and hydrogen undergo homolytic breaking, means one electron goes towards carbon and second electron goes towards hydrogen. Okay, now here carbon acquires unpaired electron, while this hydrogen atom having unpaired electron and chlorine having unpaired electron, they share their electron. Hydrogen and chlorine both are having single electron. They share their electron to form covalent bond, and thus there is a HCl as a byproduct, while carbon having unpaired electron, and this carbon which having unpaired electron is nothing but the free radical. This is the methyl free radical, and thus in second step there is a formation of methyl free radical. Now this methyl free radical further react with the another molecule of chlorine. It react with the another molecule of chlorine, and again that chlorine molecule undergo homolytic bond breaking. There is a decomposition. Now one chlorine having one electron, second chlorine having second electron. Now this chlorine which having unpaired electron, while this carbon which having unpaired electron, they share their electron to form a covalent bond between carbon and chlorine. Okay, this carbon which having unpaired electron, while this chlorine having unpaired electron, they share their electron to form a bond between carbon and chlorine, while that another chlorine acquire and again unpaired electron. Okay, this is the byproduct, the chlorine having unpaired electron, while this is nothing but a new bond, new covalent bond between carbon and chlorine. Okay, this is the methyl chloride. And thus methane, when it reacted with the chlorine in presence of ultraviolet light, we get methyl chloride, and this reaction involves formation of free radicals as an intermediate. Okay, actually, this is a chain reaction. Actually, this is the chain reaction. In first step, one chlorine undergo decomposition, one chlorine undergo dissociation. There is a homolytic breaking, and we get the chlorine free radical. Further, that chlorine free radical attack on the methane molecule, and we get methyl free radical. This methyl free radical further react with the new molecule of chlorine. We get methyl chloride. Now here again there is the formation of chlorine free radical. This chlorine free radical further react with another molecule of methane, and again there is a formation of methyl chloride, etc. There is a chain reaction, and we get the methyl chloride. We also get the dichloromethane, trichloromethane, and tetrachloromethane in this reaction. But it's a खूप detailed discussion कारण already you have studied that reaction undergraduate level, and therefore I'm not going to discuss in detail again. Okay, this is just an example of photochlorination reaction. Now let us see one more example regarding the same addition reaction. Now, suppose this is simple example of alkene CH2 double bond CH2. This is ethene molecule. When it comes in contact with any free radical, suppose it comes in contact with the methyl free radical. Now what happens here? Now here, in between that carbon and carbon 2 carbon atom, there is a double bond. One is a sigma and second is the pi bond. Comparatively, that pi bond is a weak, and this bond undergo homolytic breaking. One electron goes towards carbon, another electron goes towards another carbon. Means in presence of methyl free radical, in presence of this methyl free radical, this pi bond undergo homolytic breaking. Okay, now that carbon acquires unpaired electron. Now this unpaired electron of this carbon, while unpaired electron of methyl free radical, they share their electron to form a covalent bond. म्हणजे हा मिथिल ग्रुप आणि इथला CH2 यामध्ये नवीन बॉन्डचं फॉर्मेशन होतं, while this electron goes towards carbon and it acquire unpaired electrons. Okay, this is the product actually. This is the new bond between methyl group and carbon. हा मिथिल ग्रुप आणि कार्बनच्या मधला हा नवीन बॉन्ड आहे actually, while that terminal carbon having unpaired electron, and thus free radical, particularly alkyl free radical, when comes in contact with the double bonded compound, then we get the another free radical, and this is just example of addition reaction. Addition of alkyl free radical takes place, and we get the another higher free radical. Now let us see one more interesting example, very interesting example. What is meant by anti-Markovnikov's rule? We will see what is anti-Markovnikov's rule and what is the role of free radical in the mechanism. I will take a very simple example of addition reaction. Okay, this is example of again alkene. The name of compound is a propene, and this is unsymmetrical alkene. When this propene is treated with HBr, now what should be the possibility? When any alkene is treated with hydrogen halide, then addition of that HBr takes place across the C double bond C. One atom adds to, means hydrogen adds to one carbon, bromine adds to another carbon, and we get the addition product. Okay, this is simple addition. Here there are two possibilities. Means suppose hydrogen adds to this carbon, while bromine adds to this carbon, we get the compound. Okay, this is the compound CH3, single bond CH2, single bond CH2, and Br. Okay, this is and propyl bromide. This is one possibility. Now there is one more possibility that hydrogen can be added to terminal carbon, while bromine should be added to that central carbon, and we get another product. Suppose bromine adds to that central carbon, we get CH3, CH, Br, CH3, and this is isopropyl bromide. This is isopropyl bromide, and thus propene, when it reacted with HBr, we are having mixture of two products. One is a N-propyl bromide, second is the isopropyl bromide, and this isopropyl bromide is Markovnikov's product. Markovnikov's rule काय सांगतो आहे? Suppose any unsymmetrical alkene comes in contact with unsymmetrical reagent, then negative part of the reagent. What is the negative part in this case? Bromine is the negative part. Okay, negative part of the reagent adds to that carbon which carrying less number of hydrogen. म्हणजे Br ची addition कुठे होणार? To the carbon which having less number of hydrogen. Therefore, bromine adds to that central carbon, while hydrogen should be added to that terminal carbon, and we should be get that isopropyl bromide. Okay, this is according to the Markovnikov's rule. And here that isopropyl bromide should be formed as a major product. Okay, this is Markovnikov's rule. But suppose that reaction is carried out in the presence of peroxide. Then what happens? In this case, we get mixture of these two products. But here, this first product is in major amount. It is actually anti-Markovnikov's product. Suppose the reaction is carried out in presence of peroxide, then addition of HBr to the unsymmetrical alkene to the propene takes place according to anti-Markovnikov's rule. And here we are having N-propyl bromide as a major product than isopropyl bromide. Here isopropyl bromide is in minor amount. Why this happens? This is due to the peroxide, presence of peroxide. And this is called anti-Markovnikov's rule. Now we will see in mechanism why there is a formation of N-propyl bromide as a major product. Means we will see mechanism of anti-Markovnikov's rule. Actually, what is the role of peroxide or what is the role of free radical in this reaction? Okay, now we will see mechanism. Okay, this is our unsymmetrical alkene. This is our propane molecule. And in the presence of peroxide, what happens? In the presence of peroxide, that HBr, okay, this is our HBr, hydrogen bromide actually, it undergo homolytic breaking. Means one electron goes towards hydrogen, one electron goes towards bromine, hydrogen acquires unpaired electron, bromine also acquires unpaired electron, and there is a formation of free radical. In first step, there is a homolytic bond breaking and we get free radical. Okay, now that bromine free radical combined with unsymmetrical alkene in presence of bromine free radical, the pi bond between these two carbon undergo breaking. That's a breaking hota. This is also homolytic bond breaking. One electron goes towards one carbon, another electron goes towards another carbon. Okay, now this bromine free radical in first step combined with that alkene. म्हणजे काय होतं तर या कार्बनवरचा अनपेड इलेक्ट्रॉन आणि ब्रोमिनचा अनपेड इलेक्ट्रॉन, there is a formation of covalent bond. There is a formation of, this is sharing of electron. ठीक है. Now there are two possibilities. That bromine can combine with terminal carbon or it can be attack on the central carbon. तो दोन्ही कार्बन वरती अटॅक करू शकतो. आपण बघूया. सपोज ब्रोमिन कंबाईन विथ दॅट टर्मिनल कार्बन, म्हणजे इथला अनपेड इलेक्ट्रॉन आणि या कार्बनवरचा अनपेड इलेक्ट्रॉन यामध्ये बॉन्ड तयार झाला, इथं नवीन बॉन्ड. ओके ओके. त्यानंतर इथला जो सेंट्रल कार्बन आहे इट हॅव्हिंग अनपेड इलेक्ट्रॉन, त्यावरती अनपेड इलेक्ट्रॉन दाखवतोय. अँड दस वी आर हॅव्हिंग इंटरमिडिएट. We are having intermediate. Okay, this is the intermediate. This is first possibility. Now let us see, there is one more possibility. Bromine free radical can be attack on the central carbon. त्याचा अटॅक सेंट्रल कार्बन वरती होऊ शकतो. म्हणजे सेंट्रल कार्बन आणि ब्रोमिनच्या मध्ये बॉन्डचं फॉर्मेशन होतं. ओके, दिस इज द न्यू बॉन्ड सेंट्रल कार्बन आणि ब्रोमिनच्या मध्ये. while टर्मिनल कार्बन now having unpaired electron. आता टर्मिनल कार्बन वरती unpaired electron आहे. This is primary free radical, while this one is the example of secondary free radical. We know that among that primary and secondary, which is more stable? Which is more stable? Yes, always secondary free radicals are more stable. Means that the secondary free radical is more stable. This one is the more stable. आणि म्हणून काय होतं? Bromine can form a bond with that terminal carbon, and there is a formation of more stable secondary free radical. In next step, hydrogen free radical combined with that central HA बरोबर combine होतो, and there is a formation of CS3, CS2, CS2Br and propyl bromide, that is anti-Markovnikov's product. आणि इथे सुद्धा तीच पॉसिबिलिटी आहे. हा जो हायड्रोजन आहे तो याच्या बरोबर कंबाईन होईल आणि आपल्याला हा मार्कोनिकॉफ प्रॉडक्ट मिळतो. पण दोन्हीमध्ये मेजर कोणता आहे तर अँटी मार्कोनिकॉफ जो आहे तो मेजर असेल आणि हा मात्र मार्कोनिकॉफ हा माइंडर असेल. व्हाय दिस हॅपन? यस, वी कॅन एक्सप्लेन ऑन द बेसिस ऑफ रूल ऑफ द फ्री रॅडिकल इन दिस रिएक्शन. या रिएक्शन मध्ये फ्री रॅडिकलचा काय रोल आहे ते आपण एक्सप्लेन केलेला आहे. अँड ऑन दॅट बेसिस वी कॅन एक्सप्लेन व्हाय देयर इज अ फॉर्मेशन ऑफ अँटी मार्कोनिकॉफ प्रॉडक्ट इन मेजर amount. And this is just about the third reaction intermediate free radical. या ठिकाणी हा third reaction intermediate जो आहे तोही आपला संपलेला आहे. We have studied first three reaction intermediates in detail. One carbocation, second carbanion, and third one is the free radical.